But it's very quick. Geez, it's like a fast CPU, that's for sure. Okay, I'm going to put that there. All right. You guys can see my screen? No, you're seeing the wrong screen. Oops. Should be screen
Yep.
view.
Yeah. Was your Teams window?
It should be this one. There we go. Okay.
Yep.
Okay, cool. Alrighty. So this is, I think, where we left stuff last week. I have actually quickly in the background, just when I moved stuff to this new laptop, I just quickly did I fixed up to PureScript 0.14 and Spago 0.19.1. I didn't think I touched anything else, and everything just kind of worked. So I had to do, I mean, it actually guides you through it, something called upgrade set or something, a Spago upgrade set. So it points to a new package set, that one, PSC 0.19 something. So, and it kind of just did it. I didn't have any issues. Stuff just worked. I hope stuff just works. I did run our app, and it seemed to be doing what it was still doing last week. So just underneath, it's now the 0.14 compiler. I still haven't looked at really what the big differences are. So I'm hoping very little will affect us, hopefully. But anyway, is there any? I know we talked about this funny. I think we ended off last week like getting stuck into what is this thing, this functor map thingy. There's probably like another bunch of time we should spend on functor and bind specifically, but I didn't want to get like too hung up on it just while we like focused on trying to build a web thing, you know, almost like let's flex our muscles building a webby thing, and maybe we don't like totally understand what this bind thing is doing other than like, oh cool, it's like a promise.then, right, in the context of concur. And actually it kind of makes sense to me that, you know, that it's like when we look at this code we go, well, like knowing with concur we've got a separate, you know, they've got this the really the strong concept of like components in space is important. So like, where do components lay out? And often this would be like, okay, you have elements with children, right? And it's like children like in an array, you know, an array of components. And so it's like, okay, that just nests sort of hierarchically. So components in space lay out hierarchically. There is another way to do it. It doesn't always have to be like through this array, but you can also use this funny little thing, which we can play with a little bit later. It really, in my mind, is the same as the array one. And the second one is components over time. And this is the interesting one. So components in space make sense. Like you put an input box and a button next to each other. You know, they live at the same time. Like, or a component is a composition of components in space. You know, like a higher level component has lower level children components inside it. That's cool. And they lay out either in space or they lay out over time. And that's quite interesting. So that's where we use composition and this like bind operator, because we say, hey, these are the components. So when we think of these, when we look at this code here, we can see this is composition of components in space. We have a div parent that holds three children, which is an input box, a button, and a text, and just some text. And you can see that they're like laid out in space, right? They're sort of beneath, they're inside that div, if that makes sense. So I mean, we can understand how that looks. It looks like div opens, that's that parent one, and inside that we have an input, you know, whatever, and we have a button, and we have some text. Like that's literally what that maps to, right? That div element. This little first. So often, you know, a lot of elements have got two arrays. The first array is often it's kind of attributes. That would be something up here, like class equals dog or something. That would be class dog. I mean, this is not perfect, but that's the idea. The first array being its attributes, and the second array being its children. Comfortable with that? Matt should be comfortable with this. This is very Elmy, right? Bhavesh, are you comfortable with that?
Yeah, makes sense so far.
Yeah. Okay, good. Okay, so this looks like that. No problem. So we have a div and that's composition in space. And then it's like, oh, okay, but we're building a component that's going to do stuff over time, right? And that's where we're binding it. So it's like this. You can almost imagine this as a single element, and it kind of is. It's a div. That it's that parent element. Just happens to also hold some children. But this div kind of lifts up. So like when it runs, any of the sort of events, I suppose, that can be generated by it or by any of its children will lift up and execute whatever it's composed against, if that makes sense. So here we can see we've got this on change and this on click. Those things are the events that will be lifted up and pumped into the bind, like into the subsequently bound thing, if that makes sense, right? So this action, this is a function that's going to be executed, being passed action, which will be whatever the event is that this thing generated. That makes sense. And so that could be this on change or this on click. And we were like, well, we don't just want the on change and the on click. We want to do something with it. So we want to convert it into something that's meaningful. I'm going to get rid of this stuff here, which was we had decided inside that component, hey, like we've got two actions that we think are interesting. Either the username can be changed or the button can be clicked. So let's like make that like a first class citizen. First, like let's describe that as data. And so that on change becomes the username changed. That button being clicked generates the button clicked event, which then becomes that action there. And it's like, well, what do we do with it? Our current kind of dumb example is like, well, we do very little with it other than just like put ourselves back on the, like, don't, replace ourselves with ourself, just a newer version of ourself, which is the GitHub widget, either where the counter stays the same, but we change the name that the username changed event generated, or when you click the button, increment the counter and don't change the username. Well, we wouldn't be able to change the username anyway. I can go to new name here. If I press save, hopefully I get a compile error because it don't know what that is. Or yes, I've got compile errors up here. It's like, well, new name doesn't exist, so it's like, cool, like actually we can't even mess this up. It has to be the username. That's the only string we have, actually. Does that make sense? So one of the cool things when I look at this, I go, okay, we're starting to understand that there's like a bit of a flow of what our component is going to do. Like, first of all, it's going to start with like inputting the username. Then like the second thing that will happen is like click the button. And then probably what should happen is like, okay, so by clicking the button, we now have the GitHub username, probably. The second one, then number 3 is we should go and like fetch, go and actually hit the GitHub. I actually have the URL for what it is somewhere. Let me find it quickly. I think we want to hit this API. Yeah. So if we've got, like if it's my username, there we go, api.github.com/users/the person's name, we get back this interesting jobby. And like actually what we want is we want to get the avatar URL. So if we get that avatar URL and we hit that, it's like, oh, cool, there's a picture of the dude, right? So that's what we want to build. We want a person to type their username up there, click the button, go and fetch that API, go and get that URL, and then like render that URL, to the DOM, right? And that should do it. That should be our solution. So it's like, okay, cool. So fetch the URL, and then number 4 is like render the avatar. I think it's called avatar underscore URL or something. Yeah. Does that make sense? So we could probably separate these into different, like we could of course build all this logic into this one little widget, but like let's do it OCD wise, right? So like first of all, maybe this widget, GitHub widget, is really all he's interested is, like his job is to just do this thing, like get the person's username, and when they click the button, just give back the username that was typed in. Do you know what I mean? So I'm just going to start refactoring this thing. So I'm going to call this the username widget or something. We know we don't need this counter thing. That was kind of for fun. We can keep this username, that little piece there. That's fine. So we definitely want to click the button. We're happy with that. When the username is changed, we want that. Yeah, okay, so there's no counter anymore. When the button is clicked, however, down here, we do want to resolve. We want this like username widget to be done. Like he is over. He's done his job, and he can disappear. So from an in-time perspective, like he has nothing more to do, right? So he almost needs to resolve. And we kind of know how to do that. So we can just say like, well, actually, oh yeah, let's kill this int up there. So it's just given a string, which is the starting username, I suppose, return us back the widget, but it must resolve with a string, probably. You know what I mean? So down here, we can kill that counter there, sorry. And that looks okay. Oh yeah, we've renamed this thingy. So let's do that. Button click username. This is still going to do nothing, I assume. What's wrong with this guy? Oh, it's the wrong name again. Okay, let's just get it compiling again. There it is compiling. It's not doing it perfectly yet. So we do stuff, we click the button, and it's like not resolving it. Okay, so we know that when we click this button, it's probably this. Like we mustn't be ourselves anymore. We just want to resolve. So it's like, well, what do we want to resolve with? It's probably the username, right? We want to kind of return up the username. Does that make sense? So now, and so this maybe gets a little bit interesting, but it's like, if we look at our compiler error, it's saying it could not match the type string with a widget of an array react element string. We can, like one big clue here would be like, let's ignore this thing, because widget array react element, like if we look up here, it's widget HTML. We can ignore that little piece there for now. Like I don't understand it, and I actually don't need to understand it, but I know that this is that HTML thing. So here it's just could not match type string with widget of string, widget HTML string. Does that make sense? So what we're needing to do is we need to kind of lift it back up into this widget type. And as soon as you see that missing, you should think of the word pure. And why is that? So I think earlier we might have talked about this. So say, for example, we were saying, hey, A is a list of int, right? And and I go A equals 5. It's really probably the same compiler error. Sorry, let's make this array. Yeah, it's like could not match type int with type array of int, right? So it's like, yes, absolutely. This is not an array of int. This is an int. But if this could say, I mean, this could absolutely say int with widget of int. Like just look at the pattern, like the type speech. It doesn't matter that it's array. It's just something of int, right? We want to put that int into the something of int. And the word pure does that for us. Pure. Like check, it's gone. So it's like, what is happening here actually? So let's look at what pure does. Pure, ignoring all the stuff at the beginning, which we'll come back to. It's like, given an A, I'll give you a something of A. Does that make sense? So it's like, oh, okay, I've got an int. I can give you a list of int, or an array of int, or a widget of int, or anything of int. Any of that make sense? Of course, it's based on the fact. I mean, it's not universally true. It's true. Sorry, the signature keeps disappearing. It's only true for some things that are of type applicative. And it's like, okay, well, we don't really know what an applicative is, but know that all applicative is the thing called pure. It's this function, pure. So wherever someone has anything that is an applicative has the pure method, which means you can just put an element into that thing without even knowing what that thing is. So like, I don't know what a widget is. There's no like equals, new widget with a username or something like that. It's like, I don't even know, but I know that I can't convert my int, my string, into a type of something of string. My first go-to thing would be like, well, hopefully it's an applicative, because if it is, like, I don't even have to care about it. I can just say it's the pure. It's a pure username. Pure. We'll call the applicative implementation of how to do that for that type. Does that stuff make any sense? Pure is a bit of an interesting one, but pure is very powerful. So like I can go, hey, A is a, so earlier we had array, yes, array of int. B is a list of int, C is a maybe of int, and D is, think of another one, a something of a something. Okay, that's maybe good enough. For all of these things, I can use pure. So I can say A equals pure of 5, B equals pure of 10, C equals pure of 8, and these will all be fine. I've got to include list. Let's just do that. Data.list. And look, they all work. So it's like, oh, C is a pure of 8. So it's like definitely a just. You know what I mean? This would be the same as saying just of 8. It's certainly not a nothing. So you'll probably find, so when I call pure, like I actually don't care. It's almost like I've taken this thing and I've made that a Z. Like I don't care about what holds it. You know what I mean? But I know that it's an int. So I'm going to just put it into that thing, and the compiler will deal with which implementation it will call. Any of that make sense? So it's like we're almost abstracting away that thing. Weird? Make sense?
A
Makes
little
sense.
weird.
But it is a bit weird.
It is weird. We can dig into exactly why. It's actually very simple. So like if I, because we know about type classes sort of, right? So this seems like, so let's like control click on pure here and we'll see, oh, okay. So here's the implementation. So it's like, okay, it is, okay, this is always a little bit weird to understand, but it is called applicative. Applicative inherits from something called apply. And that's okay. That's what the syntax means. So type classes themselves can have an inheritance sort of relationship. So applicative just needs, hey, anything that is of type applicative needs a function called pure, where given an anything, it must return a something of that anything. And so it's an applicative of type F. So this would be applicative of list needs, given an A, I'll give you a list of that A. Because remember, list doesn't care about what type it holds. It can be a list of int or strings or whatever. So the A is like, it's for any type of A. Applicative of F must return a F of that A. So applicative of list must return a list of A. That's kind of how you would read that. And we should be able to find some instances of applicative for different things. Here we go. Oh, here's the array one. So applicative for array, where pure of x equals, check it out. It's like, oh, it's a single array with just that element inside it. Perfect. That's exactly what we thought it would be, right? So when we go, here's that exact one. A is an array of int. A equals pure of 5. What that means, it is like an array with 5 inside it. Do you know what I mean? It's wrapped. It's put a single element into that array. There's the implementation, right? What else would we'd have to find an instance of, like, let's see if we can find the maybe one. Can't click on that, unfortunately. Let's go to maybe, and we'll find its applicative. Yeah, there we go. Like, check how simple this is. So applicative or maybe
Wow.
where pure equals just. Lovely. So like given it is just the same as just. So when we said here maybe pure, yeah, maybe of int, pure 8, we know that that is exactly the same as just. How cool is that, right? List of int, I mean, I'm assuming it will be applicative. I can't spell it. There it is. Applicative of list, where pure of A equals A const onto the empty list. So that's a list of one element, right? Happy with that. So that's like anything that implements applicative has got this pure. And like you kind of expect it in quite a few places. So I'm pretty sure if we go and have a look at widget, let's see if we can find its applicative. This is a deriving new type instance. Okay, so derive new type instance. So derive is actually getting the compiler to write some code for you. This might be it, and we may not get through this. I think we're kind of stuck here. So this is some super advanced stuff. Yeah, I don't know, but know that know that it is of type applicative. So it looks like widget is a functor. It has bind, it has applicative, it has apply, it has a monad rec, and probably some other instances. Are those all of them? Oh, it's also a semi-group, it's a monoid, it has alt, it has a plus, it has an alternative. So it's like that type there widget is quite a powerhouse. He's got a whole bunch of things that you can expect to do on him. He has a monad effect, he has a monad AFF. Effect and AFF are like related. And so we can expect to be able to use like all of our cool functions that we know with these widget type things. Anyway,
Tom, sorry, I
yeah,
have a question. If you were, creating your own type, for example, and you implemented an applicative that looked like that, would you be able to use pure on like an int to squash it like into your type?
yeah, exactly. Yes, absolutely. Yeah. That's exactly the point. So if I'm writing my own type of thing, all I need to do in order for people to be able to use pure on it is I need to implement the applicative like type class for my type. That's definitely the idea. Yes.
Very cool.
Yeah. That's kind of the idea. So you kind of get used to these. You get used to things like in the language you get used to stuff like using hash dollar this thing, that thing, that thing, that thing, and this thing and this thing. You get used to like what do these things do, and then just use them for all libraries. You know what I mean? Because you can expect that anything that's written well for PureScript will implement like what all of these things mean within their context. So it's like your code just becomes like I know that they're quite scary initially when you see these horrible things, but you kind of get used to the fact that you kind of know what Pure does. Pure lifts something up, like lifts an element up into the applicative type. This thing voids either the left or the right side. This thing is that bind kind of action. This thing is like the functor type of action, and that's the opposite of it. So it's like, oh, cool. And there's a ton more of these things. I think there's something like that, which is like Clacy type composition. There's a couple of other. I can't remember if it's exactly this. I don't know. And so it's like you don't have to go and relearn all the new ways of using widget. You just kind of use the stuff that you're used to using. You know what I mean? You just bind and you use pure or whatever. They just work subtly different, for whatever they're trying to achieve. If that makes sense. So it can be a bit of a minefield to get through them initially. But like once you do, and you go, oh, okay, I know how it works now in Concur, probably when you pick up another library, you'll be like you can sort of map the feeling you had with working with Concur to this new library. Just by using the same ideas and like sort of digging through it a little bit. Like I just look at this widget and I go, okay, cool. I mean, I don't have to understand like how they've probably done something really smart about how these things derive or whatever. It's like, oh, okay, cool. I can do functor, bind, applicative, apply, monad, brilliant, shift map. Okay, awesome. Like it's a powerhouse. Okay, I can semi-group them in monoid. So when I see semi-group, I go, oh, that's interesting. That means I can use append on them, which is like concat. You know the way we append stuff together with strings, like Tom append with Matt or something like that. That function there is append from semi-group. So it's like, oh, cool, because like append actually will work between any type. So now we know that widgets can be appended together. It's like, oh, that's interesting. So what does that even mean? So if I take a widget and append it to another one, does that like create a new widget? And it like, probably does, right? Kind of makes sense. And those words are a bit scary, but once you attach semi-group to this thing, the ability to join things together, it's like, oh, okay, just widgets are joinable. I can join them together. It was pretty cool. Anyway, here we've solved it. So we've got a username widget now. Why have I got an error here? Oh yeah, because there's no a up here anymore. So now this is like a concrete widget. Give me a string, I will be a component that in time may actually resolve to a string again. So you give me, I suppose this is like the default, the starting username, and I'll give you the ending username when the guy clicked the button. So we can actually try this. let's just make another dumb widget, like a dumb widget, which takes a string and gives us a widget of A. So this thing doesn't do anything yet, but and the reason I'm doing this, sorry, actually let me be more clear about why I'm doing this. Yeah, okay, so if we just run this and I type Tom up here and I click hello, it's like, oh, it disappears. So it's like, oh, I gave you back the string, and it's like you didn't do anything with it, right? So I'm going to make a dumb widget which is going to do something with the string. Given that string, I'll do something. We don't know what it is yet. It's probably, let's just write the text. I got a username. Given a username, and we probably have to do that, something like that. This needs to be have a for all of a. Okay, cool. So we've got a dumb widget that when given a username, we'll just put some text on the thing saying I got a username. So like, here's the cool thing actually. Here's something very cool about Concur is like, now we can use composition so we run this widget in DOM and we just bind that onto the dumb widget. So like there we're doing, oh look, the higher level widget username grabber, like when you resolve, just like bind yourself to that dumb widget. So like pass in time down to that guy. So he'll get that username and display it. So let's test it. Press hello, I got a thing. It's like, ah, oh, so cool. Look at that. Look, your OCD should be firing here, Bhavesh, where you go, ah, I can refactor this, like these tiny little functions, these tiny little components I can start to break apart and almost reuse them. You know what I mean? So it's like, okay, cool. So probably it's not actually a dumb widget because we kind of know what we want to do after. Yeah, it's like, oh, fetch the URL. So it's like, okay, so this widget should be fetch avatar URL or something is maybe what he's called. So he gets given a username and he must reply, and let's just not do this yet, but he must reply with that thing. Do you know what I mean? So given this username, we want him to return like, oh, not that. Yes, that, yeah. Yeah. So obviously he needs to probably make a request first. So like make a request to that. You know what I mean? Username. And then return something like that, right? And we know that this thing is now going to return this new URL. So let's call that a string. Does that just work? This is probably going to tell us, oh, it's not a dumb widget anymore. It's a fetch. This thing is saying, oh, look, couldn't match string with widget of string. So what do we do here when we see that pattern? It's like, oh, we need to put it inside this other thing. There's our string. There's our string. How do we put it inside the other thing?
Pure it.
We pure it. There we go. Done. So then we get that. Okay, so we'll come back and do this part, but let's just put the little workflow together. Cool. So then when we return this little URL, oh, we should have kept our dumb widget. Let's not call it dumb widget. What about print string widget? Is a string with a widget HTML of a print string given a str. It's a d.text of I got plus that str. And this is a for all a, something like that. So right now, let's just do it, see what happens. Press hello. Something happened. Yes, we're not printing the string. So it's like, oh yes, we should bind it to print string like that. Try it again. Ah, I got the URL. Brilliant. So like, well, what do we do with the URL? What do we think?
Render.
Render it. Cool. Render image. I don't know. For all a, probably. Given a string, which is the URL, we want a widget of HTML of a. We're not sure what to do with it yet. Given the, let's call it like image URL. We could probably call that something else. Okay, so how do we do that? It's probably d.image, yeah. And then one of the attributes, because we want to be writing something like this: image source equals blah, I guess, something like that. So I'm literally guessing here what this should be. We know that P are the props inside this thing, P dot source, cool. Image URL. That might be the answer. Depends on whether image, look, it only takes props. So image can't have children, whereas div, when I look at div, oh, why? Sometimes it doesn't. It has props and it has an array of things. So divs have got properties and children. Image only has properties, no children. And that makes sense because I don't know if that's valid to have something else, a hello inside the image tag. I don't know if that's supported. Well, it isn't supported in Concur. Concur doesn't allow you to have children underneath your image, which kind of makes sense. So now we can just pump that to render image. Let's see what happens. Press hello. Oh, check it out. So pretty awesome, right? We've componentized all the little steps inside the GitHub widget. So now we could even just say like this whole chain of things here is the GitHub widget, right? So we can go GitHub widget equals these things. You know what I mean? Like it's just the composition of these three things. And now we just want to render the GitHub widget into our page. And it's like, oh, yeah, perfect. Do you know what I mean? So like here's composition at its finest. We're saying the GitHub widget is a username widget, which becomes a fetch avatar URL widget, which becomes a render image widget. Does that make sense? Comments? Confusion?
I have a question.
Yeah.
On the username widget, do you have to take in a string? Like, is that first parameter even necessary?
Well, we do because later on we invoke it again with the username in that text box.
Ah,
and
yes.
So we're
Okay.
using it as like the internal state. But we don't have to. We could hide this because we know that it's it's almost like a default value. You know what I mean?
Yeah, yeah.
So what you could do
Similar
is you
to how
could
you
say,
did the sum right at the beginning.
Yes, exactly. So, and like my dumb approach would be like if you hated that you saw this blank string whenever you used username widget, is like probably just make a username widget prime equals username widget with that. Do you know what I mean? And it's like, so maybe make this one the prime one then, and make that one the non-prime one. And this now means that you've got username widget is of type that thing. What's the issue there? Is it because this thing is defined later? Oh, it could be. Maybe it's an ordering problem? No. Username widget.
I think it might be the recursive call.
Oh, there.
Did prime.
Yeah, there we go. Yeah, 100%. So it's like we've just made a simpler one, and now we can drop that thing there. You know what I mean?
Okay. Yeah, that makes sense. Cool. Thank you.
I'd say that's common. So that's just a way of hiding it. The other way you could also hide it is you could define this thing inside this thing. That's also okay. Like this could actually be as part of a let. You go let username widget thing equals this whole thing inside this function. So like you didn't have to expose this out to everybody. It could be hidden inside this version as just a parameter or whatever. Anyway, yeah. I'm going to kill it for simplicity. Yeah, this thing is saying it. Yeah, I mean the warnings here are like just because of types. Widget HTML of nothing, right? Of type A. For all A, because the GitHub widget never resolves, after render image, nothing occurs. So it doesn't resolve to any type here. And like the compiler's checking that. If I say, hey, it actually resolves to a string, maybe it would be okay with that. Yeah, it is okay with that. I suppose it just never does. So at no point do we ever like resolve a string. So that's why I typically would keep it open, because it's like, I don't know. I don't know what type it is yet. So it's like, well, it's like any type or no type. It's an unknown type. Are we happy with that before we try and solve this problem? Because at the moment, it doesn't matter what we type in here, right? We know that we're passing the names, but it's just going to render that hard-coded URL. Now we want to like figure out how do we make an AJAX request effectively, right? To get that thing there. Any other questions? Matt, happy? Bhavesh? Who else is actually on here? Is it just you guys?
Hello.
Who's that? Daniel.
I finally found time. So I have
Hey,
no
well
idea
done.
what's going on, but it looks interesting.
It's just web stuff. You would have heard
Yeah.
of web stuff.
Yeah, I think so.
You're welcome
Okay.
to ask questions. You're welcome to ask questions.
Thanks, Tom.
Okay, so should we try and make an AJAX request here?
Yes.
Okay, so the one I have used is called AffJacks. That's what I've used. And it was fairly simple. So it was this guy. Oh, let's hope that this actually works in PureScript Node 14. Let's try it. Install AffJacks. Cool. If you're using that in Node, which we're not, okay, so if you're using Node.js, you want that library as well. Yeah, okay, here we go. Let's just steal their little thingy here. So ax.request. Okay, so yes, all right, fine. So they've got these two imports, response format and AffJacks. Okay, let's pull those guys in as AX. It seems to compile. Now we're going to go, so like let's forget about this guy for a minute and the do, and probably this. We're going to go ax.request. I actually think, is there a simpler one? ax.get. We actually just want an ax.get. Look here, this is what we want, right? So the fetch avatar URL, let's keep that comment here. That's fine. We're going to go something like that, response format of, so let's be cool here. Let's go let the URL equal, that's not the right one. Sorry, it's that one, right? Yes, as a string attached to the username. Okay. And then we need it in. All right. Do I need to indent that? In. What do I erase here? Could not match type. Okay, good. Okay, so it's like, we're returning this thing and it's saying it doesn't match widget HTML string. That's kind of our error. Could not match the type AFF with widget of something. It's like, okay, that's fine. Good. So we know we want to go ax.get. Let's have a look at what they do. We say, hey, the response format is a JSON. That sounds good. And there's the URL. We want to provide it. So let's give it the URL there. And so let's go and see what does ax.get do. I don't want to just copy their thing perfectly. ax.get AffJacks. And we should hopefully find a get request here. Yes, okay. So what we give it a response format as its first parameter, a response format of type a URL, and we get back an AFF, so a something, which inside it holds an either of error or response. Okay, so that's cool. We know about either. We know that either has this left and right thing, right? The left will hold the error, and it could be set to error, or it could be set to response. So that's kind of like our exception handling type of thingy. So we know that, I wonder what the best way to write this would be. We could just do this in another let maybe, or we go, I think, so I'm trying to figure out how best to explain this, but like I kind of know that because this is a something of an either of an error or response, it's like it's an AFF, right? That's the higher level type. So this is the thing that we can bind to. I'm pretty sure we can bind to AFF. Let's go and have a look. So if we look at what is AFF, it's like, oh, it's also, oh, guess what? It's like, oh, we can do functor type stuff on it. We can do apply, applicative, bind, monad, semi-group, so we can append, we can join them. They're monoids, they're alts, they're pluses, they're whatever. So it's like, oh, cool, okay. So when I see that kind of thing, it's like, well, how do I get to the thing inside it? And it's like, probably we would bind it, you know what I mean? And we would get the result. And so what is so now when we bind it, we kind of unpack that AFF piece, and now our result is the thing inside. And we can go and confirm that. So let's go and have a look at what does bind for, bind for AFF do. Oh, we actually have to look at the source. Where is bind? It's set to underscore bind. So it's like, okay, cool. What is underscore bind? Who knows? But it's like given an AFF of A and then a function given an A, give me back an AFF of B, I'll give you back the AFF of B. So it's like, okay, cool, yes. So the function I need to give it is something that, given the thing it holds, return back an AFF of B. So it's like, fine. Anyway, here we've got it. Result will be the right type. I wish it would be cool if our compiler would tell us that result is of type either, what is its type again? Either of error or response of type A. So it's like, okay, so what do we do when it's an either? We've got to case match it, right? So we go case result of. I don't know why this offline thing keeps thinking it wants to be there. So left would be like our error, and right would be our response. Does that make sense? Maybe. So here's a dumb approach. Let's try this. Let's see what happens. But so like I almost want to debug this a little bit. So like I'm just going to return, because our errors are going to be something about like this thing is not of type this thing. So let's just make it. So we go like pure, there was an error and there was not an error. Probably doesn't know about left. Yeah, okay, so we need to import it. Probably the same thing here. Oh, okay, fine, yes. So this pure, so this is a bit weird. When we're calling pure here, this thing is still saying, hey, wait, you couldn't match AFF with widget. And it's probably because the implementation of pure that's being called here is of AFF's implementation of pure. So there's probably a way, and now this is definitely going to sound strange, but let's just search for lift AFF probably. AFF.class. It could be this. Let's just try this. Lift AFF there. Lift AFF there. Doesn't know what this is. Import that function. Does that go away? No. Could not attach. What is AFF? So what we're needing to do is we almost need to convert from an AFF, which is an AFF holding the string, to a widget holding that string. And I'm trying to remember exactly how to do that. It might be something we'd see inside our widget. Let's see where, see, like this widget does know about AFFs. AFF action. Oh, there we go. Lift AFF. Given a monad AFF, widget a instance, monad AFF. I do think that this lift AFF is what we want.
Maybe you just imported the wrong one.
Yeah, it could be. Yeah, it could be. Although that looks like the class. Maybe it could be that it's maybe we don't want a pure. Like, let's just lift that guy. Surely it must be this one. String with type AFF. Okay. Pure makes sense. AFF dot. Ah, maybe we want to lift this actually. Yeah, that's the problem. Sorry, I was like lifting, you know, like inside the bindy thing. But actually, if you think about like what does fetch avatar return? It's like it's of that type. It's like here's what it returns. It's this thing, the ax.get with this stuff. So we have to lift that piece up. So like this is quite strange. This lifty stuff, I'm not 100% sure how to explain it, but it's like we're converting. It's almost like we're transforming from one something of something to a different something else of something. You know what I mean? And often there are these little escape hatches, which are often called lift. You'll see the word lift everywhere. So you'll find like lift effect, which is like, oh, going from an effect of something, like an effect of string, to a something of a. So it's like, oh, this could be an effect lifted into some other kind of thing, as long as it is of constrained by monad effect, like it can be lifted into that type. So it's like lifting means almost transforming it into a different type. And so because we're working in Concur, Concur needs these things to be widgets. Right here, we switch into this different thing called AFF in order to do this stuff. And we have to convert it back, make sure that we convert it back to a widget type of thing. But let's see what happens here actually. So what are we actually doing here? We go, so we get the URL, and when if we get an error, we just say, we return the string, there was an error, and when there's a response, there was not an error. Okay, and the fetch avatar goes to a render image. So it's like, that's going to be a bit weird. We don't want to render, this is not a URL to be rendered, but we could do a print string, I suppose, there. We could print that thing. So we could type a username here, press hello, did that recompile? Probably not. Ah, there we go. Okay, so that's better. I got there was not an error. Okay, so that's cool. What did we actually get? I suppose if we typed like an invalid username here, what would happen? God, there was not an error. So it's probably like their URL will, you know, it doesn't matter what you pass here, give you back something. Oh, okay, so it's like, it's always gives you back like valid JSON. It's not like, probably if I disconnected my network or something, I would get there was an error. I don't know. So anyway, the interesting thing is like, well, what do we do when we have a bad, like an error occurring? And it's like probably, I don't know. It's a good question. There was an error. Like that's probably invalid. So it's good. Like we have to think about what should we do at this point. What should the widget do? Should it, I don't know, must it return like a hard-coded URL or something? I mean, we are saying we will give you back a string. We are kind of guaranteeing that. And so maybe this is already saying like this is not 100% right. Maybe this should be like a maybe of type string or something, because maybe that would imply like a nothing or something. But let's go with it for now. There was an error. This is probably wrong. What do we do with the response? So let's go back to AffJacks, wherever he was. So this was, oops, AffJacks. This is right. Yeah. Well, let's go look at the PureScript. Oh, not the repository. I want the get. This is on Pursuit, yeah? Didn't I have a cooler picture of this earlier? Okay. Well, let's
In the-
let's just look here.
They
Yeah,
read
sorry.
me some stuff. In the repository, they readme had some examples.
Oh, was it in the repo? This one.
Yeah,
Actually,
I
this,
think
I can kind of see it. So it's like you can see on the right, you get the response, and then it's like, okay, they go stringify response.body, but let's go back to pursuit. Why is this thing being so funny? Repository package, maybe. These are kind of not the, I'm like looking for that one maybe. Yeah, there we go. I just wanted to see the get. Yeah, there we go. So we know that on the right, it's a response of type A. And it's like, well, what is the A? It's this response format. So we gave response format.json. I suppose if we go and look at that, let's not bother. Response.a, there we go. So response of A is a record. It has a body, which is of type A, but it has a headers with an array of response headers, status of a status code, and a status text. That's cool. So response.body will give us something of type A. What is that A? A is whatever we passed in to our response format up there. So if we go look at response format A, we see JSON. JSON is a response capital pass through the little j, yeah. But there is a capital J is the type. So the type is there. So it's almost like you've got this thing called response.body, which is of type JSON with a capital J. So what is that JSON? Let's click at it. Okay, so it's like some kind of JSON data type. That's fine. And I've looked through this stuff. This is in Argonaut, yeah. So the thing I found, which was useful, was decode. There's a function in here somewhere called decode JSON. There we go. So given a JSON, which we know we have, is the response.body. So let's just actually do it. Decode JSON, given a response.body, I'll give you back an either of a decode error or an A. And it's like, okay, well, what is that A? That's interesting. But let's try it. So let's just do this case decode JSON that of. So we know it's an either. So it's like left. This would be like a decode error or something. Decode error. And it's like, cool, let's just do that. There was a decode error. But if we get a right, we've got a something, like a something of type A. Let's just do that. Does this compile? Decode JSON probably needs to come from, oh yeah, we probably have to import this thing. Argonaut codex. Let's pull that in. Hopefully also works on PureScript 1.4. Unknown value decode JSON. Hopefully now it can like import it. Yeah. Yep. Response.body. Yes, okay. So probably decode JSON. Like we've got to be pretty explicit about like, well, what is that thing? It's a type of either what. And we haven't we haven't told it like what this thing is. So when we get a response from GitHub, it's like, well, what is this type? That's what it wants to decode it into, right? And I just kind of know through playing with this is it's like we could decode this as a record. So we can say data GitHub response is a record which has a bunch of fields. And I could go and be explicit about all of these fields here, but I'm only really interested in this one, right? This avatar URL. So I could say, well, there's an avatar URL in it, which is a string, and like create a new type. What's the issue here? Data. Oh, sorry. Should this say type? I think that should say type. Yeah. So I've got this. I've created a new type, which is a record called GitHub response. It just has one of these fields. I suppose I could add the other fields in here if I wanted to, but I just want to decode that thing. So when we call decode here, actually, what is the best way to do this? I want to make sure that the type I get back from that is like that type. Does that make sense? So let's just go let response let response be of that type, and we're going to say response is equal to decode JSON of response body. Oh wait, so it's not actually of this type. It isn't, because it's what's the issue? The value of response is undefined. Yes, this reference is not allowed. Cycle and declaration. Do I have? Oh, I've got. Can't call it response. Resp. I am expecting to see some other type. Oh, okay, yes. Record with either adjacent, because it's not actually of this type. We know that it's of type either of, what was it? Either of JSON decode error or GitHub response. Assume that one. So there's our decode, and now we can case match that thing. It looks horrible, guys. It looks terrible. We can definitely make this neater. But I think that that's maybe working. I don't know. Let's try it. So if I type something in there, press hello, I got there was not an error. So that's very nice. But can I rather go, so we know what A is now. So A is of that type. So I should be able to go a.avatar URL, right? Oh, is this thing compiling? Maybe not. Hey, check it out. Is that my avatar URL? It is. So let's render it. I get that. What's your username, Bhavesh? You do have one, Bhavesh something.
Yeah, it's my full name with my surname as well, Sooka. Sooka.
There you
Yeah.
are. Hacker man.
Hacker man.
Chart 1, 2, 3. Lego man. Matt Crockett. I don't know. Matt Croc? I can't remember. It's, well, maybe it's that. Daniel Horn. Somebody. Anyway, there we go. So like it's pretty nasty, and we can definitely like, but it works now, right? And now we can probably refactor it much more beautiful. Like this is pretty nasty. I don't think we need to do a lot of this part. Like that can probably be done in a single line. And we could probably also use, because now we know that we're getting an either here, and later on we get an either there. We could probably bind those ethers together. You know what I mean? To simplify what this thing does here. Because we know that we're going, hey, look, we always follow right. Like left and left are like, these are stupid things. Like there's probably, these are very obvious what left does. Left is just like return back some error. Right is like do this, then do this. So probably we could use bind from either. So if we look at either, there will be bind on here, no doubt, or even a cool example. Yeah. So the bind instance allows sequencing of either values and functions that return either by using the bind operator. So it's like if you bind two ethers together, anything on the left will return the left. So that'll like early escape. Right on X bound to F will execute F with X. Oh, there's even do notation for it. Yeah, there we go. Yeah, of course. So we could probably simplify this hugely just by using potentially do notation or a better or binding where we don't have to case match. But we'll do that maybe next week. Any questions, Oaks, before I let you go into the world, all armed with new knowledge?
No, I just got some catching up to, but all good.
Good. Anyone else?
No, same from me.
Are you following any of this stuff? I know.
I am a bit lost, but I guess it's also just a matter of catching up.
Yeah. Okay. Yeah. I think also it's worth like maybe trying to build this again. I think this is a cool example, like the GitHub username. Quite cool to try and build it because I think you do. I mean, like for me, I kind of know about Decode JSON. Like I'm familiar with it. It took me a long time to find that guy initially, as well as the lifting AFF stuff. And I don't remember exactly how I got to those things, other than like maybe looking at examples and seeing these things. And I think like a lot of it is through that. I mean, it's just through like Googling and reading code and going, oh, okay, decode JSON. I suppose there's some self-discovery that has to happen there.
Yeah, this is a good example. I think I'll give it a try.
Yeah. All right, cool, dudes. Have a great week.
Awesome.
Cool.
Thanks,
You
Tom.
too.
Cool. Cheers, dudes.
Bye.
Cheers.
Yeah.
Bye.